So for your reaction, what's the value of Kp? Okay, that's the same. And then what partial pressures do they give you? All right, we'll go through those again. Which one is which? E to the 0. And then chlorine is, all right. So we have this reaction, the equilibrium partial pressure is this and this. What is the equilibrium partial pressure? Oh, okay. Of the phosphorus pentachloride. So we don't even have to really set up an ice table, right? We can just set up the expression. Kp is going to equal the partial pressure of phosphorus trichloride times the partial pressure of chlorine all over the partial pressure of phosphorus pentachloride. And right, we know Kp. Kp is 321. It's unitless. We know the partial pressure of phosphorus trichloride was 1. And we know the partial pressure of chlorine was 4.5. And then, right, our unknown, we just assign X as our partial pressure of the phosphorus pentachloride. So we can multiply those two together, right? We get 321 equals 4.5 over X. Going to multiply both sides by X. And I get 321x equals 4.5. Divide both sides by 321. And X, my partial pressure of the phosphorus pentachloride, will be 4.5 divided by 321. So I would go with 3 significant figures if they were giving you 3 significant figures. So the 3 significant figures, I would say 1.40 e to the -2 would be our partial pressure of the phosphorus pentachloride. For the rest of you, I would just be careful because your partial pressures will be different, but the steps would be the same. So it's not likely that your final answer is the same as this final answer.
So if there's a coefficient in front of the in front of like the element or the component that has X or replacing with X, would I just put like 2X?
And we would also, right, if there was a coefficient in front of the phosphorus pentachloride, in that case, if there was a coefficient in front of it, this would still be X because it's our only variable. The only thing that would change would be we'd have to square it. It'd be X squared because we're plugging X into our equilibrium expression. And in the expression, if there was a coefficient of 2 up there, this would have to be squared. We will see cases where we do have X and 2X, but if you're asking about like this exact example where we know this, and this is our unknown, even if it was 2 moles of that go to 1 mole and 1 mole as our only unknown, we'd still just call it X in that case. Yeah.